Hi. Last lecture we have discussed the SOP, canonical SOP, POS, canonical POS, minterms, maxterms, all these conditions. Okay, let us see few questions. Say function is given as SOP. How to convert this into canonical SOP? Function is given as POS. How to convert into canonical POS? Write down the question. Convert the following functions. Convert the following functions into canonical form. Convert the following functions into canonical form. Into canonical form. Right. Here it is SOP, here it is POS. Let us convert this into canonical SOP and canonical POS. Now, firstly, you understand the basic concept. Here A, B, C, all terms are present, no problem. Here A and C are present, but what is missing? B is missing. Here A is present, B, C are missing. Then how to get these terms in with B and C means, we know one concept. A plus A bar, B plus B bar, C plus C bar are equal to 1. So here A, B, C bar, A bar, C. Here what is missing? B is missing. So multiply with B plus B bar. B plus B bar is how much? 1 only. Next, A into, what is missing here? B and C both are missing. Multiply with B plus B bar into C plus C bar. Sir, how can we multiply like this? You can understand. B plus B bar is 1. 1 into anything is again anything. Same function only. We are not modifying. Okay. Now you understand. A, B, C bar. A bar into BC. A bar, B bar, C. Next, A, B, A into B into C. A into B into C bar. A into B bar into C. Lastly, A into B bar into C bar. Okay. Now, please let me check if any term is repeating. How to check it? 1, 1, 0. Bar means 0, no bar means 1 for SOP. Which term is repeating here? 1, 1, 0 is repeating 2 times. You know, any term added 2 times will give only single term or same term. So you can add these 2 and you will get only 1 term. These are called redundant groupings. We should remove it. We should take only 1. Then what is the answer? A bar BC plus A bar B bar C, ABC, AB C bar, AB bar C, A B bar C bar. Now it is equal to, another way to write it is 0 1 1 3, 0 0 1, 1 1 1, 1 1 0, 1 0 1, 1 0 0. So it is also equal to sum of minterms. What are the minterms? 0, 0 0 1 means 1, 0 1 1 means 3, 1 1 1 means 7, 1 1 0 means 6. Okay, or if you write it in sequential order, 1 3, this one is 4 5 6 7. binary conversion. So what is this function in the canonical form? You can write like this or like this: sum of the minterms 1, 3, 4, 5, 6, 7. When we apply your K-map later, it is always the function must be in the canonical form only. Okay, sum of the minterms 1, 3, 4, 5, 6. This is the canonical form of this particular function. Okay, so that is how we convert the function into canonical form. What are the variables missing? Those variables plus their complements will be multiplied. Okay, now come to here. Here A plus B plus C bar, A bar plus B. What is missing here? C is missing. So take here, add addition mein we should always add 0. So add 0. How to add zeros? Multiplication mein we should multiply with 1 identity. Here we should add zeros. How to add 0 here is missing term is C. So add C into C bar. C into C bar. Anything into bar is 0. A bar, A plus, C bar. What is missing here? B is missing. So B into B bar. B into B bar is how much? 0. So here A plus B plus C bar. You know distributive property. What is X plus YZ? X plus Y into X plus Z. So here A bar plus B plus, this is X plus YZ. So X plus Y into X plus Z. A bar plus B plus C into A bar plus B plus C bar. Here also X plus YZ. So A bar A plus C bar plus B, or you can write right. So this is your function. Now in the POS, if it no bar means 0, bar means 1. Is there anything repeating? Yeah, this one is repeating. 0, 0, 1 is repeating. So it is product of max terms 1. This one is 1, 3, 4, 5. If it is repeating 2 times, we take only 1 times. No need to take 1, 2 times. So what is the answer? Product of the max terms 1, 3, 4, 5 is the answer here. Sum of the minterms 1, 3, 4, 5, 6, 7 is the answer there. So that is how to convert normal SOP or normal POS into canonical SOP and canonical POS. This is the format to convert it. Okay, copy it. Let us take one more example. Next question, write down. Convert the following function into canonical form. Please copy that function. Here, don't go by previous method. Previously, what we have done, multiply with d plus d bar, c plus c bar, d plus d bar, here b plus d bar, c plus c bar, d plus d bar. If you do like that, you end up with confusion or it may take more time. Yes or no? Because if number of variables increase, that previous method will not be suggestible. Now, let us go by another way. Here, a, b, c, d, if you take, what is my function? A bar, B, C bar, D. In terms of A, B, C, D, A must be 0, B must be 1, C must be 0, D must be 1 is the required condition. So this 11 is indicating minterm 5. So A bar, B, C bar, D is indicating what? 0, 1, 0, 1. That is minterm 5 it is indicating. Next. A bar, B bar, C. In terms of A, B, C, D, D is not present. A must be fixed. How much? 0. B must be 0. C must be 1. So D is missing. Generally what we are doing when D is missing, we are multiplying with D plus D bar. But instead of multiplying with D plus D bar is nothing but D bar means 0. D means 1. So in place of D, you take 0 and 1. This is indirectly equal to, this is common, D bar plus D only. So what is this minterm? 2. Minterm 3. Similarly, AB is present. You want A, B, C, D. Now, A and B must be 1s, C and D are not present. So we should multiply with C plus C bar, D plus D bar, or indirectly your CD can be 0, 0, 0, 1, 1, 0, 1, 1. That is the meaning. C plus C bar into D plus D bar is nothing but these 4 combinations. So what is this? Minterm 12, 13, 14, 15. Lastly, A. In terms of A, it is B, C, D can be anything. So A must be 1. B, C, D can be anything means B plus B bar, C plus C bar, D plus D bar will give 8 possible combinations. So B, C, D can be all zeros to all ones. Then it is equal to minterm 8 to 15. So now you can observe 12, 13, 14, 15 are repeated here and here also. So you can neglect one time. You can take only one time. Then what is the final function? F of A, B, C, D equal to sum of the minterms. What are they? 2, 3, 5, 8, 9, 10, 11, 12, 13, 14 and 15. So this is the way to represent this particular function in the SOP. Okay. So you can understand here, you can go by that method or this method. This is the easiest way, because for explanation we have taken all. Here all zeros to all ones means directly you can say M8 to 15. Here it starts with 12, ends with 15, all numbers between them. Okay. You can, exam point of view, you can do very fastly here. So this is the way to convert your SOP to canonical SOP. Another way for this. Okay, copy it. Okay. Let's have one previous gate question. Write down this statement. Copy that one. F of v w x y z is equal to x plus y bar z. F of v w x y z equal to x plus y bar z. Determine the number of minterms Determine the number of minterms in the canonical SOP. Determine the number of minterms in the canonical SOP form. In the canonical SOP form. Minterms means generally canonical form only. Okay, no need to express as canonical. If they say minterms also, answer will be same. So how to do this? From the previous experience, you may say the answer is like this. Sir, here X is present, V, W, Y, Z. 4 variables are not present, 4 zeros to 4 ones, 16 combinations. Here Y, Z are present, V, W, X are not present. So 3 variables are missing, 3 zeros to 3 ones, 8 combinations. 16 plus 8, 24 is the answer, sir. 24 is also given in the options, but not the right answer. Let me check. V, W, X, Y, Z. X is present, remaining all are not present, first term. So here X must be 1. Okay. Your remaining terms can be all zeros to all ones. Okay. Like this. It may get how many terms? Here, because middle term is missing, they are not sequential numbers. 4, 5, 6. After that, some other numbers will come. Okay. Because when it is like this, it will end up with 5 ones means 31. How many terms he is asking? He is not asking the expression. He is asking number of terms. How many expressions? How many terms here? 16 terms. Okay. Next. V, W, X, Y, Z. Y bar Z. Y must be 0, Z must be 1. The remaining can be all zeros to all ones. Okay. So here how many? 8, but don't take 8 because one important point here is we should remove redundant terms. The terms which are repeating, we should remove it. How to remove it? You can observe when X is 1, all possibilities we have covered here. Yes or no? So when X is 1, you see 0, 0, 1, 0, 1. 0, 0, 1, 0, 1 here also present or not. So here, whenever X is 1, if you draw this, please understand. 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. Okay, you observe here. Whenever X is 1, those conditions are already covered. When X is 1, all possibilities are already covered there. So, remaining 1, 2, 3, 4. So, only 4 terms. So, total how many? 16 plus 4. How many you will be getting? 20 minterms. Because if they are repeating, we should not count. So, how many we have in this canonical form? 20 minterms. If you multiply with V plus V bar, W plus W bar, Y plus Y bar, Z plus Z bar, it requires more amount of time here. So simply you can do like this. So what is the answer? 20 minterms is the answer. Copy it. Let us see the next question. Write down the statement. Determine the number of minterms. Determine the number of minterms in the output expression of. Determine the number of minterms in the output expression of 6 input exclusive OR gate. Determine the number of minterms in the output expression of 6 input exclusive OR gate. 6 input exclusive OR gate. Determine the number of minterms. He is not asking number of minterms. Number of minterms in output expression of a 6 input XOR gate. Okay. Number of minterms is 2 power n. That is 2 power 5 is how much? 32. Okay. But output expression mein how many minterms are present, that we need to find in this case. Okay. For that, let us start with 2 input XOR gate. This already we discussed. So what is your y? Sigma m of the minterms 1 and 2. That is how many terms are present? 2 terms. Okay. Let us take 3 input also, then we will find some logic for this. Right. What is XOR function? We know whenever the input contains odd number of ones, then the output is equal to 1. Here how many ones are present? No ones are present. 0. How many ones are present? Only 1. Only 1 means odd. Here only 1, odd. Here 2 ones. 2 means even. Here 1. 1 means odd. Here 2 ones, even. Here 2 ones, even. Here 3 ones means odd. So whenever the input contains odd number of ones, your output is 1. Okay. Then what is your function? Sum of minterms 1, 2, 4, 7. Sum of the minterms 1, 2, 4, 7. So how many terms are present? 4 terms are present. 4 terms are present here. Clear? Now you understand here. Let us try to conclude something here from this. You see here 2 input case and 3 input case. First part is the same or not? Okay. Two terms are present. First term part is same. What about the second part? Second part is the complement of first part. 0, 1, 1, 0. Here 1, 0, 0, 1. Second part is the complement of first part in this case. So you can understand why. Why? Because whenever you write the input cases here 0, 0, 2, 0, 0, 0, 2, 0, 1, 1. Here also this part is same 0, 0, 0, 1, 1, 0, 1, 1. But here 4 zeros, but here 4 ones. So here this 0 is replaced with 1. Then previously even becomes odd. Previously odd number of ones will become here even. So this will become complement. So whenever if I make 4 input case, then what happens? First 8 will be same. In the next 8, what happens? Here 8 zeros, 8 ones will come. So in the next 8, this part will be complement of this part. The next, is it clear? First 8 as it is. Second 8 is the complement of the first 8 will come. That will be repeated and so on. Or you can say simply first case may 2 terms, second case doubles 4 terms, next case doubles 8 terms, next 16 terms, next 32 terms. Like that it will continue. Is it clear? Because the first part may 0, 1, 1, 0. If you complement, another 2 will be coming. Okay, so you understand the pattern. If you take a 4 input XOR gate, first 8 will be same in this 3 input and 4 input also. Next 8 will be complement of this part because 1 is being added in the next 8. So in the here it is 4, in the next case it will be 8, next case it will be 16. Then how to write the function is like this. 2 terms, here it is half of your total, that is total is 4 by 2. Here also 4 terms, which is here 4 terms is half of its total 8 by 2. So if you have n variable function, because 2 power 3, because 3 is the number of variables, then 2 power n by 2, which is 2 power n minus 1. So what is the n input if you have? So what is the question given by examiner? 6 input XOR gate. So 6 input means 2 power 6 minus 1, which is 2 power 5, which is 32 is the answer. So in the 6 input XOR gate, output expression will be getting how many terms? 32 terms will be present in the output expression. Like here 4. So generalized XOR gate, n input XOR will contain 2 power n minus 1 min terms in the output expression. So 6 input XOR is the question. So how many min terms will be having? 32 min terms in the output expression. Okay, copy it. Okay. Next question. It is a previous GATE question given in GATE 2015. F of ABC equal to AB plus BC plus AC. Then find F of A, B, C bar, comma, F of A, B, C whole bar, comma, C. Copy this. I'll explain the solution. First copy the question. They have given the function f of ABC. You know what is that function? AB plus BC plus AC. We call that function as 3 input majority gate. What we need to find? F of ABC bar, f of ABC whole bar, and comma C, some function. Okay. So for example, if you have taken it as x, y, z, listen here. What is your answer? Then solution is equal to xy plus yz plus zx. AB plus BC plus AC. xy plus yz plus zx. Then what is x here? What is x? X is equal to f of A, B, C bar. So f of ABC, you know, the formula is AB plus BC plus CA. But here C is replaced with C bar. Next, what is y here? F of ABC whole bar. That is AB plus BC plus CA whole bar. Already we have calculated earlier. It is a self-dual function. So A bar B bar plus B bar C bar plus C bar A bar. Because you can take complement by duality, apply individual bars and minimize. Again you get the same. Or because it is a self-dual, total bar is equal to individual bars. Then what is Z? Z is simply C. Now what is your answer? xy plus yz plus zx is equal to xy is how much? AB BC bar C bar A, x into y, A bar B bar B bar C bar C bar A bar plus yz, that is A bar B bar plus B bar C bar plus C bar A bar into Z is how much? C plus ZX, that is X is how much? AB plus BC bar plus C bar A into X, Z. Z is how much? C. Okay. So now multiply this. Okay. A, see here, A into A bar, neglect, 0. Next, B into B bar, neglect. A into A bar, neglect, because it will become 0. B into B bar, neglect. Next, C, now this into this. Yeah, you cannot neglect here. BC bar into C bar is the same. So, B, C bar, A bar, plus, now A into A bar, neglect. C bar into C bar, we cannot neglect. So, A, B bar, C bar, plus C bar, A into A bar, we can neglect. Let me check it back. A into A bar, we neglect. B into B bar, we neglect. A into A bar, we neglected. B bar into B, neglected. Okay, B into B bar, neglected. A bar, B, C bar is the function. Similarly here, A bar, neglected. A, C bar into C bar, written. Next, A bar, neglected. Here, C bar will be neglected. C bar will be neglected. A bar, B bar, C. Here A, B into C. C bar, C neglected. C bar, C neglected. So what is this function finally? A bar, B bar, C. A bar, B, C bar. A, B bar, C bar. A, B, C. So 0, 0, 1. 0, 1, 0, 1, 0, 0, 1, 1, 1. Sum of the min terms 1, 2, 4, 7, which is nothing but just now we have discussed what is this? A XOR B XOR C. So what is the answer? It is equal to A XOR B XOR C. Here it may look complex, but it is very easy. Whenever you are having a variable and its complement multiplied, you can happily neglect because x into x bar is always 0. Copy it.